Hey guys, welcome back. So today, we're working on this Generac 5500 EXL. This one comes to us from my friend Jason, who recently picked up 3 machines for $100 total. We've already fixed 2 of them. This is the last of the 3, and I'm hoping to go 3 for 3. So this one, it looks to be in pretty good shape. I would say the best shape of the 3. There are some obvious problems like this wheel, which is bent out, and we're missing a battery. But overall, the physical condition is good. Anyway, this kind of comes with a story. The person he bought this from actually had sold it to someone else a few weeks back, and that person actually returned it about 2 weeks later. So the machine went out running and making power, and it came back not making power, and subsequently, I guess the engine stopped running as well. So right now, this is essentially a paperweight, but I'm pretty optimistic. These are good engines and good generators, so I would find it unlikely that either is terminal. Anyway, just looking around the machine here, there are some signs that someone has been into it. The fuel clamp is out of place, and the ignition switch actually is kind of pulled out. And it looks like we have a little bit of funny business going on here. So this could be the reason why the engine isn't running. Anyway, my hope today is to get this machine back up and running and making power. So let me set up a little bit better and get going on this. All right, let's check the oil. Make sure we have some before we go cranking the engine over. And yeah, we do have oil. It's just about to the last thread. It's about 2 threads from the top. And the oil color looks pretty good. I don't see any issues there. So the oil checks out. Let's see if the engine rotates. I have not done that yet. It does rotate and seems to have really good compression. So yeah, I would say the engine should run as long as we have fuel and spark. So let's check the spark. Given the condition of that ignition switch, that could be the problem here. All right, and to check for spark, I'm just going to use the spark checker. So you just put it on the wire, then you pull the engine over. You want to see a green light. So I don't actually know which way is on or off. So we'll leave it where it was. And if that doesn't work, we'll try the other way. Okay, no spark. Let's try it like that. Okay, we've got spark. At least at the coil. Doesn't mean the plug is sparking, but that's good enough for now. So I'm going to put that back to off. And I'm thinking, let's add a battery. We'll crank the engine over as is and see if it shows any signs of life. Okay, so we've got electric start. I think I'm going to hold off securing the battery. I want to make sure we have a viable machine, and then we can circle back to this. And let's see if we have any fuel. Yeah, we've got a little bit. I think that's enough. So I've plugged in a light. I've turned it on. I've also got the kilowatt as well. So I'm going to get you set up right here. We'll crank the engine with the choke on, as well as the ignition, and see if this thing will start. Okay, let's give this a try. The fuel is on, choke's on, ignition's on. Let's see what we get. So the engine, surprisingly, started right up. So I don't think we have any issues there. You know, it sounded pretty good. Although, even with the choke off, it did seem a little bit rich. So potentially, we have an aftermarket carb in there. You know, it does look suspiciously clean. So we are going to have to circle back on that, most likely. And the switch actually seemed to work. So yeah, the engine looking pretty good. Now, as far as the power goes, well, we had none. So let's turn this machine around. I want to get the end cover off, the generator, and take a look inside, see if we can't see any obvious problems, and go from there. So I'm going to go easy on these bolts. I have a bad track record of breaking them because they're so small. So we're on the wimpiest setting here. And yeah, these are not coming out easily. Though that one is spinning a little. So let me just hit these a bit with a brass drift. We'll try to kind of break the threads free from the aluminum, and then we'll try this again. Turning, but it doesn't feel good. Yeah, they're all actually spinning. Okay, we got one. And I think I might smell a little electrical smell down here. But nothing obvious. So I am having flashbacks. The beacon generator I worked on a couple years ago had the same board, and it kept catching on fire. So, you know, I guess we can do a quick test to see if everything's good, you know, with the multimeter, but an even quicker test is to unplug this 3-wire connector. You know, this connects up to the system board, and if the wires are bad, or the connections are bad, or the system board is bad, then you'll get no output at all. But with this unplugged, if this board is good and everything else is good, we should actually get full power, which is about 175 volts on the 120 output. So let's try to start it like this and see if we get any output. All right, let's try this again. We'll turn the switch on, give it a bit of choke. And still no output. That light did not turn on. So either we have a problem with this board right here or something more serious with the generator. So let's break out the multimeter, run some tests, and find out where the problem is. So we can probably start actually just by removing the brushes and inspecting the condition. And once we have those off, we can test at the slip rings. So just 2 bolts holding them on. And it's kind of a tight fit. The brushes look good. So there's no broken pieces. The springs are working. So I don't think that is the problem. So let's get them out of the way for now. And we can put the multimeter on the slip ring, see what we get for a reading. So most rotors come in kind of between 40 and 70 ohms for Honda clones, but this is not a Honda clone. And I'm pretty sure the resistance on this is quite a bit lower. I want to say about 20, maybe 25 ohms. So I'm going to have to look that up. But for now, let's just make sure we don't have an open circuit and that whatever reading we get here looks reasonable. Okay, so the rotor looks good, about 10 or 11 ohms, which I think is decent for this rotor. So let's unplug the stator wires. We'll check leg 1 and leg 2 and see what we get there. And it's nice that they label their wires as well. So we've got wire 44, 22, and this last one, I'm not sure. But I think these 3 make up leg 1 and leg 2. We have these other wires here. They're a much thinner gauge, so I'm not too worried about that at this point. So similar test, we're going to check the resistance here. And I believe on this machine that 22 is the neutral. And they've actually commoned up leg 1 and leg 2. So there's no way to test them individually. And we'll know if we're on the neutral because these legs should have the same resistance. So usually around 4 or 5 ohms. Looks like we're 0.3, 0.4 on wire 44. And this other wire actually is wire 11. We should get the same reading. And we do, 0.3, 0.4. So we'll check from neutral to ground, which is checking both leg 1 and leg 2 for any short. And no. So the main outputs from the stator, they are good. Seems like the rotor is good. Really, the only other thing we can check here would be the DPE winding. So that would be these 2 black wires plugged in right here to the board. So let's get those unplugged and see where they come in at. Wow, that was pretty tight on there. So I would say these have probably never been off. Likely the original system board. Or I'm sorry, this is not a system board. The system board's behind the control panel. Okay. All right, let's check these Most DPE windings are about 0.5 ohms. Haven't looked up the spec on this, but I'm looking for something similar and not open circuit. So yeah, 2.7, that's good. That's kind of in range of what I would expect. Check it to ground. And no ground fault. So it would seem that the stator is good. Actually, before doing anything else, I'm going to get this bridge rectifier out of circuit. You can see the terminal there on the right. It is pretty cooked. And I actually just saw a little bit of arcing from it. So something is not right. That is used, I believe, for charging the battery. So I'm going to get the battery disconnected first, and then we'll pull this out. Okay, so the bridge rectifier, it should not impact the main power output. There should be 3 wires going into it, although one of them just broke off. So the wires on the side, those actually run to the charge winding. So 66A, and then we have another one here, 77A. So that's the AC going in, and then you get DC coming out, which ultimately ends up at the battery. So obviously this was not working. It looked like it got pretty hot. And the problem with that is that the battery now backfeeds the charge winding. So likely the charge winding is bad. But let's see if we can probe it and see what the resistance is at. And actually, we have 2 bridge rectifiers. So this one doesn't look as bad. Wire 77. And it looks like 66. So I'm going to have to double check what these do. You know, one of them absolutely charges the battery. And I think the other one is the DC out. There's actually DC out on the control panel. So we'll completely isolate this and run some more tests. So I don't know what the values are as far as the resistance on these. So we're going to have to look it up. So I'm willing to bet, although these windings shouldn't affect the main output, you know, if the battery backfed and cooked these windings, it may have taken out the main windings. So this one's coming in at 0.3, which is wire 66 and 77. So let's check that to ground. And that one does have a ground fault, so that winding appears to be bad. And we'll check this other one. Point 3. Let's check that one to ground. Yeah, and they both have a ground fault, so that is not good. And likely that melted the insulation and probably took out some other windings. So we know the windings here are bad, both 66A and I think the other one was 66. But did it take out the other windings? So we're going to check from 66A to the DPE. We should get no connection. And unfortunately, we do. 3 ohms. So that is not good. Let's check from 66 to the DPE. And same thing, about 3 ohms. So yeah, unfortunately that bad bridge rectifier I think took out the DPE winding and potentially more. So let's check from 66A to the main output. Yeah, and we have a fault there as well from 66A. Let's try from 77 to the main output. And yeah. So the stator, unfortunately, is bad. So the stator, unfortunately, it's bad due to a bad bridge rectifier. So I confirmed this was the one that was responsible for charging the battery. And when this failed, there was nothing preventing all the power from going into that winding. And clearly it got hot. You can see it right here. And when that happened, it broke down all the insulation pretty much on every single winding. So the stator, it's never going to make power again. So we might have an option here as far as repowering it. I do have another Generac Stator from a 7200 watt Generac of similar vintage. So there is a chance that that could be used to save this one. Either way, this one has to come off. So I'm going to remove the battery, get all these connections apart, and remove some bolts, and we'll get the stator removed from the engine. So we've got all the legs unplugged, and we have this wire right here, which I'm not sure what it is offhand. Looks like 55. Get that unplugged. All right, and we're separated from the control panel. And the blue wire we need to pull out. That's coming in from the side. That's actually the charge wire. And that's it. So we are free. We just need to remove the mounting bolts for the mounts down here. And then we can pull the stator bolts and pull this off. Okay, that stator bolt was pretty loose. And so was that one. So maybe this has been apart already. So I'm just going to use the 2-jaw puller to hopefully break this free. Sometimes the ball bearing hangs up here in the end housing. Other times it's just dirt and corrosion on the bell housing. So you want to go easy. You shouldn't be building pressure. If you are, then something's going to break. In this case, though, it's coming right off. So yeah, maybe someone has had this off recently. Oh, and it's actually the end bell, or sorry, the end housing that came off. So, you know, most generators, they have bolts that run and hold these two together, but not this one. And that might make things a little more tricky. So the stator, it's still stuck in the bell housing. So I'm going to use a dead blow hammer, see if we can't free it up. So I've got to be honest, for a bad stator, this actually looks really good. You know, I don't see any signs of overheating. None of the wires are charred or burned. The lacing is intact. And the insulating paper, no hot spots. So I may have been a little quick to condemn this stator. You know, when I did the testing, I thought we were isolated, at least on the 12-volt side. And when disconnecting this, I found that wire 55 was still connected. And even though we had the ground disconnected as well as the DPE, I did have a couple of the legs connected still to the control panel. So that may have led us down the wrong path. So let's just double check this now that it is 100% isolated and make sure we see the same fault. All right, so I'm going to start just with the 12-volt side of things again. We had wire 66, 77, and then 77A and 66A. So those were the two 12-volt circuits connected to the bridge rectifiers, and we did have a connection between them. So I'm going to check between 77 and 77A, which is the charred one. And there is a connection there, which might be okay. You know, potentially it is the same winding feeding both of those bridge rectifiers. So I wouldn't say that necessarily is a problem. Let's check from wire 77 to the DPE. And there is no connection this time. So that is interesting. This was kind of the thing that made me condemn this. You know, the DPE winding, that is usually always isolated and there's never a connection to ground or any other winding. But in this case, it seems like there's no longer a connection. So maybe the problem is the DPE to something else. And yeah, the 12-volt side of things over to leg 1 and leg 2, no issue. And we'll check it to ground. No issue there as well. So all the faults we saw before are gone, but that still doesn't explain how we got a connection to the DPE. So let's check that again to ground. No fault there. And we'll check it to leg 1. Okay. And we do have a connection. from DPE to leg 1, leg 2. So yeah, the stator actually might be bad. You know, I've never seen the DPE winding connected to anything before. So potentially the insulation failed here. Although I'm not ready to condemn it yet because, well, I have seen this once before, and actually that generator didn't make power either. So I would say the DPE winding might actually be the failure here. And I guess the last check I want to do here is just confirm what this wire 55 is. You know, it was connected when I was doing all the testing earlier, and I think that's how we got the reading from the 12 volt side over to the 120. So with one lead on here, if we check over to the main outputs, leg 1 and leg 2, I wouldn't expect a connection unless this is a ground wire or there's a neutral to ground bond. Yeah, and we do have a connection, so let's check this to the ground wire. Okay, yeah, and that's, I think, how we got the connection. So the neutral must be bonded up in the generator, so if we check, yeah, the main outputs, we also get a connection to ground. So yeah, lesson learned. You have to be isolated, and in my case, I missed that wire 55, and that essentially connected the 12 volt side over to the 120 240 side, and ultimately to the DPE winding. So at this point, I would still say this is a bad stator, just based on the connection from the DPE over to leg 1 and leg 2. That is not normal, and I've only seen it on a bad stator that wasn't making power. So just as a triple check, you know, I do have that other Generac stator from a similar machine. So that is a known good stator, so let's get that out. We'll do the same check from DPE to leg 1 and leg 2 and see if a connection exists. All right, so let's cut this open. This is a stator that actually was sent to me by a subscriber. He had purchased a generator because he needed the engine, but not the generator itself. So I have not looked at this yet, but he said he did run the machine before taking it apart, and it was making power. So if the stator that came on this machine ends up being bad, we could potentially use this. If it's exactly the same size, we can just throw it on. You know, otherwise, I also have the matching rotor. You know, we could also swap the entire thing. Huh. Definitely well packaged, though. And this stator, it's significantly larger actually than the one we just pulled off, so I'm not sure if it would fit onto this frame. And it looks like we do have the board, so if it ends up being a board issue, we can probably swap that out. We also have, it looks like, one bridge rectifier. So let's disconnect everything here. You know, we have, this is the DPE winding, the one in question, so let's get that unplugged. Okay. Here are the main outputs. And we also have, looks like that wire 55. Now all these wires, they're not actually going anywhere, so, you know, technically we are isolated. So let's grab one of the main outputs and we'll use the multimeter. Right now I have it set to test continuity, So if I hold one lead on the DPE and the other lead on one of these outputs, we get a tone. So this machine, it's a little different from most. So the DPE apparently is connected to leg 1 and leg 2, which is good news. You know, that stator, pretty sure it's good. So based on the testing we just did, you know, it would appear that the stator is good. You know, I don't see any obvious signs of a problem here. So I am going to get this reinstalled. I think before I do that, I'm going to replace at least these 2 charred connectors. You know, might as well clean up the slip rings while we're at it, and we'll get this reinstalled. You know, there are a few things we can try to get this started. You know, potentially it lost magnetism, or maybe the power control board is bad. So we have a couple options, but we can't really try any of those until this is back where it belongs. Okay, that's one. And the other wire here we want to repair is 66A. So I'm just going to use a little piece of Scotch-Brite to clean this up. Just be careful, there are some wires going into the slip rings. You don't want to knock into those. So they do break pretty easily. Anyway, I did pull the spark plug. This is going to make it a lot easier to rotate the engine and safer. And we have to pull it anyway. So once the stator's back on, you know, we do need to rotate the engine and just make sure that the rotor is not rubbing against the stator. Because if it is, and you start the engine, then that'll be pretty much it for the generator. And I think I'm also going to use a little bit of contact cleaner on the slip rings. You want to make sure they're dry. And in this case, I'm kind of contaminating it. There is some grease on the bearing that I might be transferring over here. And this is definitely putting the cart before the horse as far as cleaning this up goes, but we're never going to have better access. And I am pretty optimistic that we're going to get this to make power again. I guess the question is, will it be followed by fire and sparks? not sure, but based on the testing, I don't think that'll be the case. So I'm going to go on record and say it may not be possible to assemble this like I normally do, because the end housing isn't part of this. You might need to actually tip this up on its side and use gravity to our advantage. And the other thing to consider here too is that you can install the stator any way you like, but these wires, they were on the left side. So if you install them any other way, then things aren't going to line up properly. So I'm going to give this a few light taps, try to get the stator seated in the bell housing, but it looks like we are started. So once I'm sure that's going in, we'll then add the end housing and bolt it all down. And the sound just changed, so I think we're bottomed out, at least on the left side. Yeah, let's add the end housing now. All right, I think that's it. Yeah, before I torque down that stator, we can just rotate the engine and make sure it's not binding. And in this case, the engine doesn't rotate at all. So the alignment, it is not correct. So I'm going to loosen up these bolts. We'll get the end housing back off, just double check things, and we'll try this again. So the engine rotates fine without the end housing on. So I don't think we have an issue with the bell housing alignment, but I'm going to tap it just to make sure that it's seated again. And we'll try installing the end housing. Hopefully it doesn't lock up this time. Okay, good. The engine rotates just fine now that we reseated it. So I'm going to torque these down. You know, that should fully seat everything, and we'll just double check that things are still good. All right, I think we're good. Engine rotates just fine. So we're gonna add the feet back and connect up some of these wires. The 12-volt side I am gonna leave completely out of the equation for now. We do need new bridge rectifiers before we try that. But we are gonna need the DPE winding. So I'm actually only seeing, oh, there's the other wire. I was gonna say I was only seeing one. So we need both of those as well as the stator wires. So I'm going to get the brushes reinstalled, but not connect it to the power control board. You know, ideally, I'd hook up these leads and then supply power to the brushes using a 12-volt battery to restore magnetism if it was lost. Unfortunately, it's very tight space in here. These leads don't fit. You know, they just hit the end housing here. So instead, we're going to have to secure the brushes and then just use some alligator clips to apply the power, which is fine to use. The only issue is that, they can and do shake off sometimes when the engine starts. Another thing worth noting here too is that you should test the brushes. I actually tested them off video, but you want to measure and check for continuity between the brush and the terminal, because there is a braided copper wire in between that connects them, and sometimes that can fail. But in this case, it didn't. So we'll get the stator reconnected. Wire 44 went to the gray. 22 went to the red. Then the blue wire was kind of the mystery wire, which we later found out looks like number 11 goes to blue. And this stuff I think we'll leave as is. I might hook up a 20-watt light to the excitation winding because, sometimes these go bad. And if it can't power a 20-watt light, then that is a pretty good indicator. So we'll get that connected. And I also want to connect the ground wire, probably right there. And then I think we'll be ready to try this again. All right, so we've got the light. And we'll just connect these up like so. And I'm going to have to space these out. I don't want the DPE shorting. So bend this wire a bit. Okay. I think we're pretty much ready to go. Spark plug is reinstalled, as well as the start battery, and everything's connected that we need to test here. Now, I did add a 3 amp inline fuse for the brushes. You know, the rotor really shouldn't be pulling more than that, and I want to protect these wires. They are pretty thin. So the plan is just to get the engine started, you know, have you guys situated on this end just to see what's going on. And initially, nothing should happen. But when I connect the brushes to power, we should see this light turn on. It won't be the full 120 volts, but it should be enough to at least allow the light to glow. And I also want to see that the DPE winding can turn on this 20 watt light as well. So let's get the engine started and see what we get. All right, the fuel is still on. We'll give it some choke. Here we go. Huh. And the engine does not crank. Oh, all right. We've got a problem. All right, so this time the starter did not engage, and looking at it more closely, I can see why. You know, we have the neutral and the negative connected to the block, which is fine. We have the red coming over to the switch. And then on the outside, we actually have a black wire, which is positive, and that should run to the starter. But if you look here, that wire pulled out of the lug and is, I would say, a fraction of an inch away from touching the block. So with that, not connected to that, this is never going to work. So let's repair that real quick and try this again. So that wire should not be live, unless of course you press the switch. But I do want to try to hold this lug still, because I don't want to start twisting this whole terminal, which could internally damage the starter. Ooh, but it is turning. The lug, that is, not actually what I want. All right, it looks like that freed it up. Kind of. And you can see what I'm talking about. That lug is a little loose. You don't want that spinning, or you will cause damage internally to that starter. right, I think that'll do it. I'm just going to bump the starter. Yep, we're good. All right, take two. Choke is back on, fuel is still on. Contact. And the ignition was off. Let's try it again. Contact. Okay, and that was a good test. We just learned a lot of information. By applying power to the brushes, we saw that the light came on. So we know the brushes are good, the rotor's good, the leg 1 or leg 2 seems to be good, and the DPE winding could also power a 20-watt load. So it looks like we have all the ingredients we need for a generator that can power itself. So by powering the brushes directly, if it was a magnetism issue, that should no longer be an issue. So I'm going to get the original board reinstalled. We'll give it one last try. And if that doesn't work, we'll try the other board from the spare generator. So the original power control board, it is reinstalled, being sure that the white wire goes in the front. That is the positive for the brushes. The brushes are polarity sensitive. The DPE windings connected. I did put wire 6 in the front. That's what the wiring diagram shows, but technically this is AC input, so it shouldn't matter where these go. And I've also plugged the board back into this 3-wire connector that runs up to the system board, which is what regulates the voltage. So if this works, we should have somewhere in the neighborhood of 125 volts. So let's get the engine started and see if flashing the field made any change. All right, make sure that this system board is out of harm's way, which I think it is. So turn the ignition on, choke on, contact. So this board did not power up. And I'm willing to bet that it's the board itself. So I'm going to pull this board off. I've already disconnected most of the wires. And we'll throw the other one in its place. That should be a working board. I guess my only reservation is, should I connect it up to the system board? Because there are possible faults with the system board that could take out the board down here. So maybe I'm going to leave that 3-wire connector disconnected for now, which means the voltage is going to be high and we might blow the light bulb out, but I'd rather do that than blowing out a known good board and then still not knowing what the problem is. Okay, let's try that out. All right, so what do you think? Hopefully the light turns on because we're kind of out of options here. So we'll turn the switch on, choke on, contact. All right, so we have a different board and a different result. The light came on. Now, the voltage, it wasn't as high as I thought it was going to be. It was about 130 volts, so we could still have issues here, but the engine speed also was slower than I was expecting. You know, the last few times we tested it, I thought it was closer to 60 hertz. This time it was about 10 hertz slower, so that could explain the difference in the voltage based on the engine speed. So I'm going to get this cable reconnected. We'll start it again and see if things continue to run well. And this obviously is just temporary. You know, I'm not going to finalize any wiring until we know that we're out of the woods. All right, let's try that. All right, we'll turn the ignition on, choke on, contact. So that was a mixed result. I mean, we still have power output, but the voltage was low, and the engine speed was actually closer to where it should be. So, you know, the voltage was at 68 hertz. So, yeah, we might still have issues here, you know, potentially an incompatibility with this board versus the system board inside the control panel. And there's also a potentiometer right there. So potentially, you know, someone started playing with that when this machine stopped making power. So I'm going to do a little bit of digging, a little bit of research. And I think before we do anything too drastic, you know, we'll get this restarted, try adjusting that potentiometer, and see if we can get the voltage to where it should be at 120 volts. So I'm going to try it one more time with this snubber network disconnected, which is the 3-wire connector going to the system board. I want to see that the engine runs faster and that the voltage runs higher. You know, if it doesn't, it could be a sign that the engine was under load. You know, like potentially we might have a problem here. So yeah, let's restart it with that disconnected again. And I'm looking for something higher than 130 volts. Well, as far as the voltage goes, I'm not going to worry about that too much yet until we get the engine speed issue figured out. So, you know, the governor spring, it is installed and there is tension on it. So, you know, if the governor is doing its job, it should maintain the speed, even if there was a short circuit. You know, this should go under load. And although it did sound like it was straining a little more with the 3-wire connector unplugged, you know, I wouldn't say it was a short circuit. You know, it kind of makes sense because this is now supplying full power to the field. so the magnetic field is stronger and it's harder to rotate. So what I'm thinking is that maybe someone's using the idle set screw on the carburetor to idle this engine at 60 Hertz instead of allowing the governor to do it. So there is a set screw right there, which doesn't look like it's driven in too far. And I guess the other possibility is over here. We do have an idle solenoid right here, and you can also set what speed to idle at. So there is a physical stop, which is kind of hard to see, but you can see it just barely right there. And if I actuate the governor arm, you can see right there where it makes contact. And the fact that I can actually move the arm and make contact tells me, the idle set screw isn't setting the minimum speed. Actually, this solenoid is. So what I want to do is restart the engine with this connector connected. So we should be running at about 60, maybe 61 Hertz. And then I want to come over here and see if this metal plate is actually making contact. Like if I try to push that more closed, will the engine slow down? Or are we already at the minimum speed set by this set screw right here? All right, let's get this started. I thought we had it there for a second. It seemed like this was making contact with the solenoid. So, I backed that up, and unfortunately, there was no change. The engine was still running at about 60 Hertz. And just to make sure, I also backed off the idle set screw on the carburetor, and no change at all. So that is not a good thing. So it doesn't really explain why, when this 3-wire connector is unplugged, the engine runs quite a bit slower at about 43 Hertz. The governor should compensate for the increased field strength. So yeah, I don't know, or I don't think we have governor issues, at least none that are obvious. So yeah, I'm thinking maybe we unplug the wire, bring the speed up to 61.5 Hertz, and then we'll plug the wire back in and see where the speed is at. All right, so now we're at 61.5 Hertz when that 3-wire connector was unplugged. It's plugged back in, so there's going to be less of a load, And ideally, the engine speed wouldn't be much higher, but given the adjustment I made, I think it's going to be quite a bit higher if there's something funny going on with the governor. So I'm going to have to keep my hand on the switch to shut things down pretty quickly because I think it's going to run pretty fast. So let's try it. So we definitely have multiple issues still going on with this machine. One is the engine speed control. I think that issue can be sorted out. Either we have to change the sensitivity by moving the spring in, or potentially we need to reset the governor calibration. We know there's an aftermarket carb on there, and likely the calibration is a little bit off. So I think either or both of those two adjustments could likely fix this issue. The governor, I do feel it pushing back, so I don't think we have any internal damage with that. The more concerning thing, though, is the voltage control. I maxed out the potentiometer with that 3-wire connector plugged in, so the system board should have been able to get the voltage higher than 85 volts, and yet we couldn't. But with the 3-wire connector unplugged, we can produce 155 volts. So that, I think, is an issue. The system board is very suspect, so I think that is the next move here. I'm going to get these screws out, we'll get access to the system board, and swap it out with another. All right, change of plan. I spoke to my friend Gary. Gary is an absolute expert on the XL series of generators, and I told him about the problem I'm having, which is when this is plugged in, I have low voltage output. So he reminded me of something about the DPE winding. So when I plugged this in, I said it's AC. Technically, it shouldn't matter, but I'm going to follow the wiring diagram. And I should have followed my own advice because I thought wire 6 went in the front when actually Gary informed me that it's wire 2. So it doesn't seem like a big mistake when dealing with an AC input into a bridge rectifier, but in this case, it does make a difference because of the connection from the DPE over to the main winding. One of these wires is a direct connection to neutral on the main output, whereas the other one actually goes through the coil of the stator and as a result has a higher resistance. So if you get the wires backwards, it changes the resistance of the circuit, and this is not able to control the voltage properly. So I guess the good news is that it's an easy fix. I think if we just swap around these two leads, we might be good on the power front. So number 6 in the back, number 2 in the front. I'm going to recenter this. So right now it is turned all the way counterclockwise. And it's only about a half turn total. So right there, we're in the middle. So let's get the engine started, see where the voltage is at. We'll tweak it as needed, and hopefully we get to 120. All right, ignition's on, choke's on, and the fuel is on, although it occurs to me too, the surging we had earlier might be due to a low fuel condition. There was not a lot of fuel in that tank, but hopefully we have enough for at least one more quick test. Contact. And that was it. The AC wires were plugged in backwards. Who would have thought? But in the position that they are now, we had full control. I was able to bring the voltage down to just below 100 volts or all the way up to 100, about 45, I'd say. So I dialed it in to about 125 volts. It's extremely touchy, just very fine adjustments make a pretty big adjustment on the voltage, but we're pretty close. We're at about 125 volts. Now, the engine continues to do funny things with the speed. This time, the engine kept speeding up. I think we got up to about 65 Hertz, and I backed off the spring tension quite a bit, and the engine speed came down, but not really as much as it should have, or at least not as much as I would have expected. So I'm fairly confident that the governor is just out of adjustment, and there's no more throw to close that throttle plate. And of course, as the engine warms up, it needs less fuel and has to close that throttle plate more to maintain speed. So let's take a closer look at the calibration and see if we can make an adjustment to improve this situation. All right, so even though I backed out that idle set screw, it is out still further than it needs to be, at least for now. You know, right now we don't have idle control because we don't have the 12-volt system working, so that is backed all the way out. And to double check the governor, I mean, technically you don't have to double check it. You can just reset it. But in this case, I want to show you how to check it. And that way, once I make the adjustment, you know, we can double check it and have confidence that it's adjusted properly. So right now, the spring holds it or pulls it in wide open throttle, which in this case is to the left. So in that position, that is wide open throttle. And what you need to do is put the carburetor in wide open throttle. And you want to make sure that these align. And it's kind of hard to see. It's actually not too bad. You know, being maybe 1/8 of an inch off, you know, a few millimeters, not a big deal. And we're not as far off as I thought we were going to be. So it could have been something as simple as that idle set screw. I'm not holding my breath. I'm going to slide this off. Just take a look at the throttle plate. Make sure that's not causing any problems. And no, we do have full range of motion. So I don't think that's the issue. So yeah, I mean, it's a tiny bit off, but not really. So I don't think a governor reset's going to fix this, but we're here. Might as well do it. So we get the anti-surge spring back on, as well as the governor linkage. Okay. So yeah, I don't think that's the issue, but might as well make the adjustment. And I have seen this issue on these models, actually, where you set the idle speed to, say, 45, maybe 50 hertz. And if you do that when the engine's cold, you know, everything seems fine, but as soon as the engine warms up, you know, the speed starts to pick up. So that idle set, which used to be 45 or 50 hertz, is now, you know, racing the engine at 65 hertz. And I guess while we're here, let's take a look at this custom wiring job. Okay, so not as bad as I thought. Although I'm a little confused as to why they did it. So there's a green wire, or there used to be. No, it's still here, but it looks like the connector's gone. So there was no way to plug that in. So I think what we'll do is just extend the wire a bit, add a connector back, and I think this issue will be fixed. we've got a good connection. And I would say way more wire than we need. But that's okay. I guess we could always cut it shorter if it's too long. So we'll add this spade connector. And that should complete this repair. So I'm just going to run it for maybe a minute or so and take note of the engine speed over that time. Now, if it was the idle set screw, we should actually be running pretty slow when we first start up, so we might need to make a small adjustment. But yeah, let's get it started. We'll see where it's at and see what it does. All right, so I'm going to make an adjustment to the governor system. Now, it didn't seem like it was off, but based on the testing, it has to be off. You know, I adjusted the speed, no load speed, to about 61.5 Hertz. It seemed pretty stable. And then when I put a 1500 watt load on, the engine speed fell to about 53 Hertz, and the governor arm did not move at all. So the governor is not doing its job. And oddly enough, I just found a video I made 3 years ago. And in that video, I was fighting another 5500 XL that was doing the same thing. And in that one, I actually replaced the governor spring, had no effect. I tried changing the sensitivity, and that had no effect. And finally, I adjusted the governor, and that actually fixed the issue. So what you need to do when making this adjustment is make sure that the throttle plate is in wide open throttle. In this case, that's counterclockwise. The spring is actually holding it in that position. So as long as it stays like that, all we need to do is loosen up this bolt and rotate the shaft to the right until it stops, which is the same direction as wide open throttle, clockwise. And then we just lock it down. Okay, let's try that out. And that small adjustment seems to have fixed the issue, because this time, I set the speed to about 61.5 Hertz. I put a load on of 1500 watts, and the engine speed was pretty much unchanged. If anything, it went up a little bit to 61.8 Hertz, which is not normal. It's kind of the opposite problem. The governor might be too sensitive now. Potentially that is the surge, although it kind of felt like a carb issue. It was kind of hard to say, because even when choking it, I couldn't really get rid of the surge. So if it was purely a carb issue, choking it should get rid of the surge, and it made it a little better, but it definitely did not get rid of it. So, I'm thinking, let's move this spring out one position. I've had a lot of trouble with these Generac engines in this position, with the governor being overly sensitive. And what we just saw seems to indicate that. The engine speed should have dropped at least a little bit under a 1500 watt load. So yeah, let's move the spring out, get the engine restarted. We'll reset the speed and try this again. So by setting this further out, we're decreasing the sensitivity, which means the engine speed will sag more under load. And you would think you would want the opposite, and I guess in an ideal world you would, but on a mechanical governor system, you have to have a little bit of droop. The engine speed has to lose a bit of speed under load. Otherwise, an oscillation forms between the governor spring and the governor inside the engine, and that can mimic a carburetor surge. So let's get it restarted. I'll dial the speed back in, see if it runs any better. And interestingly enough, the engine is still maintaining almost perfect speed from no load to 1500 watts. The big difference though this time is that when I applied choke, I was able to more or less get rid of that surge. So I think we are dealing with multiple issues, and given that the engine speed is still so steady under that kind of a load, I think we need to go out one more position. So I'm going to do that real quick, probably off camera, and then I'll turn the video back on. We'll get it started again, adjust the speed, put the same load on it, and see if the engine speed actually slows down just a bit under load. All right, we're in the outermost position. So let's see what that gets us. Well, this machine's definitely giving me a run for my money. So there has been a tremendous amount wrong with it. And we're making progress. You know, the adjustments that have been made to the governor has made a very big improvement. You know, this time I could turn the choke off and the engine almost ran perfect. So potentially, if I add the airbox back on, that might push us over the finish line as far as the run condition goes. But being that this is a clone, I'm thinking we might face some struggles there. But the engine speed, you know, that issue is sorted. And I think at this point, we can start to focus in on some of the minor things, like the bent wheel, the carb jetting issues, and of course, the 12-volt system. So as far as fixing the wheel goes, I don't think it's going to be that hard. There is a tab right there that the wheel attaches to that is bent. So I was just getting ready to get the wheel off, and I started to notice that this wire right here is actually a live wire connected right to the 12 volts. You know, it's commoned up here on this post. So that is for the charging system. It's probably not good to leave that hanging around. So I'm actually going to shift gears. We'll fix the 12 volt system first and then circle back to the rest. So obviously this rectifier, it is no longer good. I believe this one is. They are both the same part number, BCT8-04. And I was just checking my stash because I did save a few parts from that beacon generator, and one of them was the bridge rectifier. And it is hard to make out, but it is the same part number, BCT8-04. So I'm going to test these real quick, make sure they're good, and if they are, we'll get them installed. All right, so we'll get these tested up. I'm sure some of you might be wondering, how is this a full bridge rectifier? There's only 2 diodes. And for any of you who watch Electro Boom, you'll know you need 4 diodes for a full bridge rectifier. You know, in this case, they're doing something pretty neat. There is a charge coil in the generator stator, and it is center tapped. So the center tap is the neutral or the negative. No diodes needed for that, but you do need 2 diodes in this rectifier to create the positive voltage. And that is because each end of the coil is changing from positive to negative. But if you connect those ends of the coil to this rectifier, then it's only going to allow the positive through whatever end of the coil happens to be positive at that moment in time. Anyway, to test this, you just want to do a voltage drop test. Positive should be allowed from either of the end spades to the center. And if it does that properly, there'll be a voltage drop. So in this case, we went from 1.51 to 0.459, which is fine. We can check the other side. So those diodes seem to be good. And then if we reverse it, we try to send negative through. Nothing should be allowed. Although in this case, it is allowing 0.001. Let's check the other side. That side seems fine. Let's check this side again. Yeah, actually both sides are doing it. So it might be my meter, or it could just be a little bit of leakage. I don't think that's an issue, but let's check the other diode, which admittedly doesn't look as good. Positive is allowed through. We get the voltage drop on both sides. And then we'll check it like we did, where it should block. That one's blocking, no voltage drop at all. And same thing with that one. So I would actually say this diode is in better shape than that one. You know, is this one still good? Maybe. But I do have another one. This one is actually from this generator right here. So let's see if this one is any better. All right, voltage drop. Voltage drop. And we reverse the leads. Actually, I did that wrong. Now the leads are reversed. And no voltage drop at all. So I'm going to go with these two. I think these are the best ones that I have. So I'm going to get the battery disconnected, just the positive. You know, to do this properly, you would actually disconnect the negative first, because the wrench, if it makes contact from negative to the frame, you're not going to have a problem. And once that's disconnected, you can't mess up disconnecting the positive. But if I disconnect this first and touch the frame and the terminal at the same time, then you're going to complete a circuit, and there's going to be some sparks. So if you do it this way, just be very aware of what your wrench is touching. But as it is, it's pretty unsafe with that live wire. You know, I'm surprised we didn't short out during testing. Okay, so things should be safe. And I'm not going to connect the rectifiers yet. I actually want to put an inline fuse on this wire to prevent the problem that almost destroyed the stator. So if the diodes fail and the power starts to empty out of the battery into the charge winding, you know, the fuse in line should blow before any damage is done. Yeah, I'm just going to get all these zip ties off. This wire, the charge wire, you know, when I add the inline fuse, we're going to have to shorten this, then zip tie everything back together. All right, so by adding this, we're obviously adding length. I do need to swap the fuse out as well. This was the 3 amp fuse that we were using for testing earlier. So I'm going to take off or cut the old wire right about there to get that extra length off. And technically, I was going to say we could probably save the sleeve, but I'm not sure it's going to go over the butt connector. All right, so we might have a little issue, not a big one, but a little one. The gauge wire I used is thicker, so it should actually be a red butt connector, but this needs the blue. So I'm going to strip a little bit more wire back. We'll just double it over, and that should help hold the crimp in place. Okay, good. And we'll make the final connection, tidy everything up, and then we'll do the wiring to the bridge rectifiers. All right, so without the fuse, that wire is not going to be live if I reconnect the battery. All right, so without the fuse, this wire, it's no longer going to be live. So we can get the battery reconnected without worry. All right, so we're going to get the neutral connected first. And of course, that was the wire 55 that gave us the false readings earlier when I condemned the stator. All right, so that is done. And then we should have 4 wires left. 66A and 77A is what we want for the charge circuit for the battery. Which are these 2 wires right here. Yep. And this is AC in, so it really shouldn't matter which side you plug this in on, as long as you plug it in on the right tabs, in this case the outer tabs. And then the blue wire, which runs to the battery for charging, goes in the center. So that is theoretically done. And then we have these 2 wires here. So these go to the control panel. There is a 12-volt output, likely also for charging batteries. So we'll get those on, and then the red wire, which runs up to that charge port. So I am going to get this reinstalled. Actually, before I do that with the fastener, let's connect the fuse and just make sure we don't have any kind of a meltdown here on this rectifier. All right, so we've got the 10 amp fuse. And yeah, no issues, at least with the machine off. Good. So I think the wiring is going to be all right, but I'm going to leave this removed until I get that rectifier firmly attached down the stator. Yeah, this bracket, I don't think it's original to the machine. You know, ideally I'd use the center holes, but that gets the metal of the bracket really close to these terminals. So instead, we're just going to try to kind of attach it here on the side. And we still get close, but at least the J-hooks are wanting to pull it away instead of toward the terminals. Yeah, that'll work. So I think if I remove the axle, we can then just get an adjustable wrench on there and bend it. Potentially, actually, we might be able to bend it using the axle. Let's try that first. I think that's all I dare bend it. I heard a crack. The welds probably can't take much more, but it looks like we are straight. So I'm going to snug this up, this bolt just a bit more before we get this fully back together. So it looks like the wheel isn't the only thing that took a hit. You know, the foot over here is bent at a pretty good angle, so we'll straighten that out as well. Yeah, still not great. So that's going up a little, and this as well. Neither one's a 90, so probably just use the same vise to try to straighten that a bit. Yeah, it's closer. Yeah, it's a little better, but this whole thing was mangled pretty bad. So we actually need this side to come in that way a little bit. So So I could squeeze it with the vise, but likely that's going to throw off this side. So maybe just pushing it down. Yeah, that's pretty close. I'd say we need a little bit more work over there. But as it is, I would say it's going to be fixed or at least unnoticeable. Good enough. And the last issue I would say is the carb. And unfortunately, I think the issue is that it's a clone. Don't think it's dirty inside, but I'm going to drop the bowl and just take a quick look. You know, it got a lot better after making the governor adjustments. So potentially adding the airbox might get us over the finish line. You know, I do have spare carbs, but nothing for this machine. And I'm pretty sure the OEM carb is available for at least $100. Actually, I'm going to take the carb off. These studs, they're just held in to a plastic manifold, and they can't take a whole lot of stress before you crack that manifold. It's not a good sign. There we go. I did see a couple chunks come out, so that gives me a bit of hope. That looks pretty clean. And yeah, a little bit of debris, but overall not too bad. And the carb, I'm just making sure it's not OEM. Actually, it is. It says Nikki right there. So yeah, I give this carb hope. Maybe just a quick clean will bring it back around. Oh yeah, we can't get the fluid off until we get the main jet out. Easier said than done. I'm going to use a different screwdriver. This one's kind of narrow, so it'll give me a little more leverage. No. So that's not coming out. And I don't want to force it. This carb's in good shape. I know the needle and seat work, so there's really no reason to take that out. You know, we can still run through that jet and just make sure it's clear. So I'm going to get the pin back in. And the emulsion tube on this one's not removable either. But the pilot jet is. And that actually could be the issue. So it's under this cap right here. So we actually need to remove the idle set screw. And this machine does idle. We're going to have to reset that probably just before load testing. You know, it has to run and be fully warmed up before you set the idle. And I think there is a teeny tiny little pilot jet in there. Let me see if I can get a small enough screwdriver to get that out. Okay, just broke free. So that one was in there, I would say almost as tight as the main jet. And that's it right there. So teeny tiny little jet, very easy to lose. And technically we could probably get this out with vice grips as well, but I don't see the need. We can clean it where it is. Yeah, main jet was nice and clear. Yeah, and the pilot, if it was clogged, it was only just barely. So I'm going to soak this probably just 5 minutes. Yeah, it doesn't need a whole lot, but we'll just make sure everything is out of the passages. And then we'll get this reconnected with the airbox installed and try it out. You know, if it's good, yeah, I'm going to drain the tank, make sure there's fresh fuel in there. And then I think we'll be ready to finally try this thing out. Carb cleaned up pretty well. Not that it was that dirty. I mean, this carb is, I would say, one of the cleaner ones that I've ever gotten on a machine. So I would say someone did maybe recently replace it in a last desperate hope to get the machine to run right. And let's see if we can get the pilot in without losing it. Okay, that is bottomed out. We'll just get the cap screw on, which is extremely important. The pilot circuit won't work without it. At least it won't draw any fuel. It'll just suck air, and the machine will not run well. and then we'll get the idle set screw back in. So I'm only going to drive this in until about 1 or 2 threads poke through. And we'll set this later when we're outside to do the load test. Okay, I'm going to get this reinstalled with the airbox, and we'll start it one last time. Make sure the 12-volt systems are working, as well as the carburetor. Looks like a homemade gasket. Which actually fits pretty well. I usually torque carbs down on this size engine to 60, maybe 70 inch-pounds. But given that these studs go right into plastic, 40 inch-pounds is about all I dare go. Even then, it makes me a bit nervous. Like right now. Okay, that one is tight. So is that one. All right, so we've got the carb and the airbox back on. The fuel is plumbed in. And I'm going to start it one more time. I just want to make sure the carb is running the engine well, and also that the 12-volt circuits are repaired. So the meter on the left, that is showing the starting battery voltage of 12.81. So once the engine's running, we want to see that voltage rising. And we also have this meter plugged in to the 12-volt output here on the front. Now that, I believe, is for charging batteries, and likely without a load on it, we could see up to 30 volts, which is fine. I just want to make sure that both circuits are working properly. And of course, I'll do a quick load test as well, and just make sure the governor continues to respond well. So the 12-volt system seems to be functioning just fine. It brought the battery voltage up. We started at 12.81, and well, now we're at 13.18, so no issues there. And we also had voltage coming out on the control panel. So the 12-volt system, I would say, is fully repaired, and the carburetor is doing pretty well under load. You know, under 1500 watts, it ran pretty much perfect, but under no load, there is an oscillation still. So the pilot circuit, it is a little bit lean. So I'm going to pull that pilot jet back out, and I might drill it just a bit, you know, one size up, and I think that should minimize or get rid of that surge. All right, so I pulled the jet off, and the largest drill bit that it fits on is a number 72, which I believe is 25 thousandths of an inch. So if we used the next size up, that would bring it to 26. But we might have another option here. I do have a Generac carb for a Generac XG8000. This is a parts carb, and it has what appears to be the same type of pilot jet. So they're probably interchangeable. And potentially this one is already larger. So I'm going to pull this one out and measure it up. And if it's a little bigger, then we'll just give this one a try. Yeah, it is larger, actually quite a bit. 1, 2, 3, 4, 5 sizes larger. So usually it's okay to go 1 or 2 larger. In this case, that might be a little bit too much. So I'm going to drill this one out at least one size bigger, and we'll try it out. And just be aware too, these bits, they do break when you try to do this sometimes. So make sure you can get another jet if you need it. You know, if it's a discontinued part, doing this is probably not advisable. You know, in my case, we could use the other, although that might have the opposite problem of overfueling it. Anyway, I'm going to get a little WD-40 in there. There's a lot of drag on that drill bit, and I don't want to snap it off. Okay, we're through. So I'm going to throw this back in. We'll start it, see if it made any difference. And that was it. That was the last piece of the puzzle. So this time, when the engine started, it did have a slight surge, but the engine too was relatively cold. So I put a 3000 watt load on to get some heat into the engine, and also to make sure the main jetting was good, which it seemed to be. So after a few seconds, I took the load off, came back here, and under a no load condition, the engine was idling pretty much perfect. So I think everything major is done, and this machine is more or less good to go. So other than draining the tank and bolting it back on, I think we're just about there. The fuel that came out actually looks pretty fresh. You know, there's no water in there, a bit of debris, but overall, very good condition fuel. What do you think I forgot? Actually, I did forget. There were so many problems with this machine. You know, the oil was kind of the least of my worries. But it's at the point now where it's absolutely earned an oil change. So we'll get some fresh oil in it. So to be honest, I didn't think we were going to get to where we are right now. This machine has had so many problems. It's been one of the most challenging fixes to date. So let's get the engine started. You know, while it's warming up, we'll double check the outputs with the kilowatt. We'll measure the frequency and the hertz. We'll use the amp probe to measure the total harmonic distortion. You know, ideally 5% or less will be safe for electronics. And I know for a fact this one is above that. But it's not as bad as a lot of newer models. I think we're going to see somewhere in the mid-teens under a full load. And we've also got the oscilloscope to see what the output looks like. So we're going to put the load on using the load bank. We'll start at about maybe 2,500 watts. We'll check the stats. If everything looks good, we'll go for the max of 5,500 watts. All right, so far so good. The engine started first full. It did have a bit of a surge though, although that has mostly worked itself out at this point now that the engine has warmed up. So without a load, we're starting at 5.7% THD, and the sine wave doesn't look terrible. So let's bring on a 2500 watt load, starting with 2000 watts. No issues, engine speed's fairly stable. Went on to 500 to that, so now we're at 2500 watts. THD did go up a bit to 14%, and the sine wave doesn't look terrible. So let's give this a few minutes. Assuming everything continues to run well, we'll go for the max of 5500 watts. Alright, so it's been a few minutes at 2500 watts, no issues. So let's bring this up to 4000 watts. Holding just fine. How about 5000? 5500. Yeah, things are holding pretty stable. THD, it looks like we're topped out at about 17.3%. And the sine wave looks largely unchanged. Not too bad. Alright, it's been a few minutes, no issues at all. The engine speed has been pretty stable at 59 Hertz, but the voltage was a bit low. It's coming in at about 115 volts under this kind of a load. So I do want to bump the no-load voltage up a bit, although technically we're probably okay at 115 volts. So just double check where it's at under no load. Yeah, so I think that should be a little higher, you know, ideally around 125 volts without a load. So let's make a small adjustment, and then we'll try full load again and see if that voltage came up a bit. Alright, the voltage has been adjusted without a load. We're pretty close to 126 volts. So let's put the 5500 load back on. So there's 2000 watts, 4000 watts, 5000 watts, 5500 watts. So under this kind of a load, we're at about 117 volts, so that is a lot better. So I'm going to take the load off, and I'm going to let things cool down, and then I'm going to shut the load bank down. I want to have this pretty much offline because we still need to set the idle control. You know, likely when I flip that switch, you know, if things aren't set right, the engine will stall. So I don't want to have any dependencies over here. So yeah, we'll give that just a few minutes, shut this down, and then we'll make the final adjustments. Alright, so I just turned on the auto idle feature, and it's not going to idle down until we turn the light off, and potentially we need to unplug the kilowatt as well. But let's start with the light. and likely the engine's going to stall. Yeah. So the engine, it is trying to stall. The problem is, as the engine speeds down or slows down, the 12-volt side of things doesn't have enough power to hold that in the idle position, so it revs back up. So let's bring in the idle screw, at least enough to keep the engine running, and then we'll make the final adjustments using the solenoid. So all things considered, this machine performed extremely well. We adjusted the voltage a tiny bit. We set the idle speed, which surprisingly I couldn't do using the set screw on the carburetor. I actually drove that all the way in, and it did not influence the engine speed at all. So we had to make the adjustment over here using the solenoid, and like that, it now idles at about 50 Hertz when the idle control is turned on and the load is turned off. So, all things considered, this machine is in great shape. And actually, this series of generator, it is one of my favorites. They are getting up there in years, so I guess the only reservation is that if you own one of these, you do need to maintain it to keep it in good form. But this is a very well-built machine. So, I hope this video helps someone. Thanks for watching.